Hello, everyone. Welcome to our monthly Science Vault Protein seminar. My name is Amy Huang, and I'm the Associate Director of Scientific Ecosystems at the Good Food Institute. And for those of you who are kind of brand new to our community here for the first time, welcome, welcome. The Good Food Institute is a nonprofit think tank that is 100% driven by philanthropy, and our goal is to build a world where alternative proteins are no longer alternative. If you are looking to take a deeper dive into the science of plant-based fermentation or cultivated meat technologies, you can check out our many open access resources at gfi.org/science. All right, and now I am delighted to introduce our speaker for today. Tim Searchinger is a senior research scholar at the School of Public and International Affairs of Princeton University. He is also a senior fellow and the technical director for agriculture, forestry, and ecosystems at the World Resources Institute, which is an organization I'm always kind of constantly inspired by. Tim's work combines ecology, agronomy, and economics to analyze the challenge of how to feed a growing world population while reducing deforestation and greenhouse gas emissions from agriculture. And I know that's something we are all thinking about on a regular basis. There is, as all of you know, a really active debate about how land use should be factored into the greenhouse gas accounting of food products. Most methods only really account for where agricultural products are generated and not how much land is used in that process. So because those considerations have a really profound significance for the extent to which and even whether alternative proteins are likely to reduce emissions relative to animal products. We're excited to invite Tim today to dive into his research and everything that he knows about this land use factor. And we can hopefully emerge from this seminar with a more accurate and comprehensive sense of how to correct carbon accounting as it relates to food production. So with that, Tim, thank you so much for being here with us today. Feel free to go ahead and share your screen and take it away. Thank you, Tim.
Thank you, Amy, and thank you for having me. It's a pleasure to be here with people doing, I know, very important work. And the part of the story here is exactly why that work is important. So a few years ago at WRI, we produced a massive report really on how to feed the world without destroying the world. And it's a challenging job, and the core of that challenge is land use. So agriculture occupies about half of the world's vegetated land, and even a larger share of that other than in kind of really cold places. And it's responsible, agriculture and forestry are responsible for about a quarter of all the carbon that people have added to the atmosphere. And we're still clearing land. So ongoing land use change for agricultural expansion is probably responsible for around 10% of all greenhouse gas emissions. And it's well known, cattle expansion into the Amazon is one of the dominant drivers. In fact, livestock expansion everywhere for grassland is the most direct, immediate cause of forest loss. And you can see the role of livestock in this chart. It's a little complicated. I'm going to come back to it later. This is what we produced in that big report. And in the US diet, what you can see is the land use that goes into that diet is represented by every color here except green. So the red is ruminant meat like beef and mutton and lamb. The orange there is dairy. The yellow is pork and poultry, basically. So the overwhelming majority of the land use and it's roughly a hectare per person per year for the US diet, comes from livestock products. And the production emissions as well, about 2/3 come from livestock products. And globally, it's not that much less. So from that, you automatically know that livestock are a key driver of our demand for livestock products are a key driver of this land use change. There's also expansion in Southeast Asia for palm oil, for example. That's another driver, but basically it's mostly livestock. And On what we now have a pretty good sense that of what's happening with cropland. It's hard to know statistically, but we had a good study a few years ago from satellites. And basically it found that annual cropland was expanding by about 10 million hectares per year. Now that's all this stuff in red. It's a gain of cropland. Um, there's probably another million hectares that wasn't in that study, which was things like oil palm, so-called permanent crops. So about 11 million hectares per year now. Now that is almost the size of England every year, or England here every year. And if you do it for 30 years, that means you're going to clear an area the size of India. And that's not even counting pasture expansion. Um, what's driving this, of course, is the growing demand for food. And we estimated from 2010 to 2050 an increase in the amount of sheer calories that people would consume of more than 50%, about 56% here. But we also estimated a 70% growth in demand for animal products. And you can see that that's basically been going on. If I continued this, it would still go on that. This is meat, dairy is going on roughly the same driver. Now, when pretty much any modeler estimates what it's going to take, to even with yield gains to do this, the models almost always estimate large land use change. Here's just the cropland expansion. Almost 400 million hectares here, sometimes less. It depends on what level of yield gain they have. But we don't just need to avoid clearing land. In fact, as you probably know, there's a big focus on natural climate solutions, the importance of that. That's basically things like reforesting land. In order to do that, you have to be able to shrink your agricultural land. And in fact, these are these complicated slides. I don't ask you to look at them too much. These are pathways to potentially holding climate change to 1.5 degrees warmer, which is the nominal goal of the Paris Agreement. And what you see is the brown here. The brown is emissions from land use change. And what you see is it has to go to negative by 2050, which means we not only have to stop clearing land in these almost all these scenarios, we actually have to reduce our agricultural land. So that's the problem, right? We've got predicted expansion. We have a need to reduce the agricultural land to solve climate change. This is key, critical for biodiversity and other reasons. And just to give you some idea of how challenging that is, in the 2050 study, in our 2019 paper, we predicted different scenarios for land use change between now and 2050 due to agricultural expansion. So if yields grew at kind of the historical rate, we estimated that 600 million hectares would be cleared, about 200 for cropland, 400 for pasture. If yields grew only at the kind of more recent growth rates, it would be even more than that. It would be about 800 million hectares. Now, if yields didn't grow at all, we'd end up clearing 3 billion hectares of land. To give you some idea, that's about 4 times the size of the continental US. And it basically wouldn't have a forest left in the temperates or tropics. So that includes historical rates of yield gain. That's the key point, and it's still a huge challenge. And if that's not enough of a problem, this is really a great slide that my colleague Richard Waite put together that shows why and how really big a problem this is. So I'm going to explain this in some detail. Across the x-axis here is the population by country or region expected to be in each place by 2050. So almost 10 billion people, you can see these different locations. In the y-axis is their per capita consumption of dairy products, of all livestock products. Or I guess this is meat. I guess this is just meat. And no, it is livestock, sorry, includes dairy. Now, the red is their per capita consumption in 2010. And what you see from that is that more than 6 billion people in 2050 are likely to live in countries where today's consumption of animal products is about 1/4 of that in the Western world. And in the estimates we did, we assumed that that consumption was only going to go up to half for about 2/3 of these people, but still remain at only a quarter for about one-third of them. So more than 2 billion people. So this shows you two things. One is there's this kind of inexorable demand for meat or milk growth as hopefully poor people get wealthier, but also that even the estimates I provided could be worse. What would be the story if all these people tried to consume the same amount of animal products as in China, let alone the US or Europe? So that helps to explain the challenge. Now, if we want to think about how we solve the challenge, the simple way of thinking about it is we have to minimize what you could call our land carbon footprint, the amount of carbon lost from land when we clear vegetation and soils and put their carbon into the atmosphere. We have to minimize the amount of that we lose. So native vegetation stores all this carbon in trees, shrubs, grasses, and in soils. When we clear that land for agriculture, we lose basically all the carbon in the vegetation and maybe 25% of the carbon in the upper layers of the soils. And we have to minimize that carbon footprint. Okay, so how do you do that? Well, if you need more food and more carbon storage, but we have a fixed area of land, there are only two ways to do it. They both involve increasing land use efficiency. One is to produce more efficiently, basically higher yields, and the other is to consume more efficiently, which means we have to consume food products that require less land. Okay, so now let's think about that. That is what we need to solve climate change. Now, how do we count land use in typical greenhouse gas accounting? And that this accounting occurs in different contexts: national accounting by countries, life cycle accounting, where we're trying to kind of advise consumers often what the greenhouse gas emissions are of the products they consume, and company GHG emissions, including using something called the GHG protocol, which WRI helps to put out, and which basically incorporates a kind of a life cycle approach, but for companies. And how do these typically now deal with land use? Well, I'm going to argue inadequately. So the most common way they deal with land use is if you directly cause land use change, if you clear land yourself to produce something, we count the emissions. Or if you're a company or you're consuming a product that was made on recently cleared land, we count those emissions. But that means if you're on existing agricultural land, no matter how much you use, you don't count the emissions. Now, another tool, the other basic tool, is something called statistical land use change. And this typically is sometimes used when people don't really know where their products come from, but they know which country they come from. And it works something like this. You've got here, kind of roughly speaking, the brown areas are kind of the agricultural lands in Brazil, not completely, but it gives you some idea. You say, okay, we have this existing agricultural land and we deforest a certain amount each year. Now, look, what if you grow soybeans somewhere in this land? Well, the way it will work is you look at the emissions from annual land use change. You divide that by the total national crop production. So you have the marginal emissions from land use change and you divide by the total production. A little bit of land use change, the total production. And that ends up with a pretty small number because you're taking a marginal change, how much is caused by the increased demand for soybeans, let's say, and you're dividing it by the total amount of soybeans. So you end up with a small number. So one aspect of this is the number's pretty small. But both of these rules basically say the following. If you get your soybeans, let's say, from a place that's having land use change, we're going to count emissions. That's bad. If you get them from places where we cleared land in the past, that's fine. So if you want to claim that your products, your meat, let's say, which uses soybeans, does not have any emissions from land use change, it's very simple. You get your soybeans from the US, not from Brazil. Voila, no emissions from land use change. And what this means is how much land you use doesn't matter. So these are where standards, not how much standards. So how much land you use to produce something doesn't enter into the greenhouse gas costs. Using that land more efficiently doesn't enter into the greenhouse gas reduction. Using a plant-based meat that uses less land has no land use effect, no land use savings relative to even beef, let's say, so long as your beef is being produced on land that was cleared in the past, as in virtually all of the US. I'm going to skip that. Now, how should we count land? Well, the cost of something is always its opportunity cost. So economists, you take your introductory economics, the first thing you learn is the reason something has a cost is because it could be used in another way. And the cost is not using it another way. And that could be a car, that could be land, it could, for financially, it could be a ball, it could be anything, labor. But for carbon, that's also true. And what's the alternative uses of land if you don't need to use that land for your consumption? Well, one is you just use the land to produce food for others. And the carbon benefit, it avoids agricultural expansion. You're holding down the global demand for land. And if we didn't actually need all that land for agriculture, it would still have a cost, which is that you could allow that land to regrow forests or other native vegetation. Continuing to use that land for agriculture has this opportunity cost. So the basic point of this is from a climate perspective, just like from a financial perspective, land isn't free. If you use it one way, you lose the benefit of using it another way. And one of those benefits is producing food so that we don't have to clear as much land. Now, another simple way of thinking about it is this. When we do a life cycle calculation of the costs of the climate costs of a car, we have to factor in the costs, all the costs of making the car. And one of those costs is making the car factory. So if this has substantial emissions, what you have to do is take some of those emissions, a little bit of the emissions assigned to each car. So costs of making a car include the costs of making the car factory. No one disputes that. Well, to make crops, you have to start by making cropland. So the cost of making crops includes the cost of making cropland. And we have to amortize that like cars over some number of years of crops that we produce. Now notice, when you buy a car, the car factory has already been produced. It's already happened in the past, but we don't say, oh, therefore there are no emissions from the car factory. And the reason is we know that overall, the more cars people produce, the more car factories we're going to have. So if you consume a car, somewhere we're going to need to have another car factory. Well, the same is true of crops. In a world where we're expanding crops, if you consume crops, we're going to need to produce more cropland. So it's the same thing, and we should factor in those costs. So in 2018, we had a paper in Nature where we did this. We estimated what we called the carbon opportunity cost in this way for all the different food products. And it was done in a very simple way, actually conceptually. A lot of work, but conceptually very simple. They say, how much carbon is lost from vegetation and soils used to produce a product globally, beef, soybeans, or lentil? And then you divide that by some number of years of producing that. Now, we actually use a fairly sophisticated time discounting system to say, look, it's more important. What are the costs of clearing land in the next 30 years, let's say? where we really need to deal with climate change. It's really important that we avoid emissions in that time. We use a kind of a time discounting approach. You could also just divide it by 20 or 30 years, which is typically what we do when we do direct land use change. So that's it. And so basically we know what or we can estimate what the native carbon stocks were on vegetation before it was cleared for agriculture. We know we have some estimate of where all the different crops are produced. This is for corn. And you basically take this, divide by these number of hectares. You find this for these hectares, divide by that. You get a amount of carbon loss ultimately per hectare, and then you can get that per ton of corn, and you can get that per ton of corn annualized, like divided by 30. And that you get that kind of a number, the carbon opportunity cost. That's the annual cost. And you can do that for livestock products, looking at all the grazing land that's been carved out of forests, looking at all the crops that go into it. So basically, for a livestock product, the cost is the carbon opportunity cost of the land used to produce the livestock products. Now, when we do that, this is what we see. So these are the production emissions from agriculture, meaning the methane, the nitrous oxide, the emissions from fossil energy used to run tractors. And you can see they're in the dark green. And it is true that, even for production emissions, they're higher than for grains. But the big, big numbers are these annualized land use costs. And you can think of this as the amount of carbon we could save if we produce, in this case, 1 less kilogram of protein from beef. That's the amount of carbon that we could save from that additional avoided kilogram of protein. And that would be per year and then multiplied by 30 years. Now, just to give you some idea of why this means, this is complicated, this chart with more of these numbers, but I just want to focus on a few to understand why these numbers work out. So maize, of course, the international word for corn in the US, and wheat, it turns out they have a very similar carbon opportunity cost. Now that's interesting. Corn is grown on land. Our corn has higher yields than wheat globally, but it's grown on land with higher carbon stock. And when you balance it out, it turns out they're very similar. Soybeans are grown on very similar land to corn, but soybeans have lower yields, so we therefore have a higher loss. Now look at beef and look at pork. They're dramatically higher, and they're higher because we require huge amounts of land. Beef uses a lot of native grazing land, but actually of the roughly 3 billion hectares of grazing land in the world, 40% originally came from forests or woodlands. And that's why you have these big costs. Okay. Now, what are the implications of factoring in the carbon opportunity cost of land versus not? The first one is, as I've already shown, is that if you don't factor in the land use cost, food choices don't matter that much. So, I showed that basically here. They matter, but that's not that big. Let me show it this way. This was our estimate of the carbon costs of diets in kind of a high meat diet in Europe. And basically what you could see here is that with these estimates, the gray is the big number. That's the land use cost. And these are just the production emissions. And when you add them together, this number per person per year, these are tons of CO2 per person per year, that number is roughly equal to the usual estimated emissions for the average European for everything, including food. So the food sector alone is emitting as much carbon, if you factor in this land use cost, as people typically estimate is consumed by Europeans for all products. And the reason that is the case is they don't factor in this land use cost. And you can see the big benefits of switching to alternative diets with less beef or less meat in general, a vegan diet you can see over here. I showed you this chart before. This is calculated a slightly different way, but roughly the equivalent of carbon opportunity costs. In the US, we estimated when you factor in these kind of annualized land use costs, the US diet causes about 15 tons of carbon, of CO2 per person per year, nearly all from livestock products. And that is roughly equal to the emissions of our emissions of energy in the US per person. But again, if you weren't going to factor in these land use costs, you wouldn't think it was that big a deal. So another reason to do this is otherwise we can get kind of improper claims. So an example of that is carbon neutral beef. So this is an example of claiming carbon neutral beef. What did they do here? They took a hectare of cropland, they converted it to grazing land. When you convert cropland to grazing land, you sequester carbon in the soil. And they estimated that the amount of carbon they would sequester in the soil matched the amount of methane from the cattle and said they had carbon neutral beef. Well, the problem with that is that you're producing about 1/10 to 1/15 the amount of food on that land when you're using it for grazing than for crops. So that's not a sustainable strategy, right? Somebody converts cropland to grassland in one place, and somebody else is going to have to do the opposite. And another version of this is some people want to claim carbon neutral beef because they basically just plant some trees on half of their grassland and count the carbon sequestered by those trees. And they say that cancels out the emissions from the beef. Well, they're just producing less beef on that land. And so therefore that beef has to go somewhere else. So there is a carbon opportunity cost to converting that land to grassland that you would have to factor in. If you factored that in, you'd find out this doesn't really generate any benefit. Now, what would generate a benefit is there are silvipastoral systems where they use trees and shrubs and they get more output per hectare as well as some carbon. So that would be an example of really reducing emissions per kilogram of beef. But this one is just, you just take half the field and you turn it into forest or some planted trees and you claim that you have carbon neutral beef. Another implication is we can just get away with outsourcing. In a way, that was just kind of outsourcing one farm to another. Europe's policy now, Europe has a climate policy where to basically outsource. So this was a paper I had in Nature last year or 2 years ago, a year and a half ago. What you see here, I won't explain it all, is this is what you could call the imported land carbon footprint of Europe. So the amount of land carbon lost from land used to produce food that Europe imports, this is the exports. The net deficit is about 400 million tons, which is huge. That's about equal to all the benefit of growing forests in Europe. Despite that fact, their climate strategy, oh boy, their climate strategy was to take a fifth of EU cropland out of production to turn it in for energy crops, claiming all these benefits, even though what effectively they're going to do is just import more food and cause more deforestation abroad. And that's done because no cost is assigned to diverting cropland to another use, no carbon opportunity cost. The land is viewed as essentially free from a climate perspective. Well, what about plant-based or cultivated meat? Well, this is where obviously people here most focused. So this was one paper, and it compared essentially a hamburger in Ireland or Brazil to a veggie burger. And yes, even without land use costs, there's a savings, but it's a lot smaller than when you factor in the land use costs, the carbon opportunity costs. So yeah, you might do it, but it's not that big a deal. If you factor in the land use costs, it's a really big deal. And in fact, it's even more so. This was not my estimate, but just knowing the difference between the production emissions and land use of, let's say, Brazil versus the US, this would be the small difference if you don't factor in the land use costs. But this is a much bigger difference in the US if you factor in those land use costs. Here's another study I just saw. And what's important for this is you see that for some animal products, it's really all about the land. So for example, the production emissions of eggs or poultry are actually lower, according to this study, than the production emissions of, let's say, an Impossible Burger or even a chicken patty, if you only count the production emissions. But if you count the land use, then these products are much better. So let me just, this is kind of the key point of the argument. I'm going to give you a kind of as an academic, I'm going to give you kind of another logical argument for why we have to factor in the carbon opportunity cost. So economists will tell you that if you want to do something perfectly, you impose a universal price on something. So you can imagine theoretically what the world would, how we could solve climate change if we had a perfect global carbon price. Now, we can't have it. There's political reasons, practical reasons we can't have it. But you can prove theoretically that if you had a perfect global carbon price, that'd be the most efficient way of solving climate change. And you wouldn't have these situations where someone is simply claiming to reduce emissions while transferring emissions to someone else. Now, what would happen if you had a perfect global carbon price? Well, if you burn oil, you'd pay $100 per ton, let's say. Let's assume that's, just for purposes now, that's the cost. Well, if you clear forest, that means you also pay $100 per ton of CO2 that you lose. If you had a perfect global carbon price, if you reforested land, someone would pay you $100 per ton. Now, what this means is that using land for any purpose other than to store carbon becomes very expensive, because if you clear land, you have to pay this amount. That's like $40,000 per hectare in Brazil, let's say, or in much of the tropics. This might be worth like $1,500 per hectare per year. You'd have to forego those to use that land for any other purpose. So to avoid that, you would basically have a big focus. Here, let me put here, you avoid that, you'd have a big focus on increasing yields on existing land. And the price of using land, let's say for beef, which is extremely land intensive, would go up until it can compete with the value of just using that land to store carbon. So people would have a big incentive to consume food products that store less land, and they'd have a big incentive to use land with higher yields, better grazing, all these other kinds of higher efficiencies. And you wouldn't need any other form of accounting because the price would tell us everything we need to do to solve climate change. Now, that, as I said, would have huge implications, right? We would be trying to avoid land meat, particularly ruminant meat products that use huge amounts of land. Why is that? In effect, what we would have is a system where land was valued for its carbon opportunity cost. Now, we have these other accounting systems like life cycle calculations because we don't have a perfect global carbon price. But we know that they will only be correct if they value land the same way. So I do want to just leave you with this thought that even though I'm a huge advocate, I believe that there is probably no way to kind of avoid catastrophic land use change unless we find ways to moderate diets of their animal product consumption. So less consumption by those in the West who consume huge quantities, particularly of beef. And we have to have ways of keeping the growth of animal products in developing countries down, which means we need to give them legitimate alternatives, which is, of course, where all of you come in. So that's really important. But I'm also a realist and know that it's a massive, massive job. We're looking at gigantic increases in consumption, which means we also need to produce more efficiently. So I actually spend a lot of time focused on improving animal production, including examples of improved grazing practices in Latin America. So I just want to emphasize we need both more efficient production and more efficient consumption, but both depend, valuing those depend on actually valuing land properly. And I'll leave you just with this one slide. And the basic point is that typical life cycle calculations or other accounting treats land as free from a climate perspective. If you clear new land, okay, that's got a cost. But all of that existing agricultural land is treated as free. No matter how much you use it, there's no climate cost. No matter how much you improve the use of it, there's no climate benefit. And what you're seeing here is a map of an estimate of the annual amount of plant uptake. And it's finite. You can see that it's not only is land finite, there are only so many parts of the world that have enough water or the right temperature to grow plants well. Human beings have not increased this. They've decreased this total amount of plant growth. In a few places, they've increased it, but at a huge cost. For example, in China, where with heavy irrigation, or parts of India with heavy irrigation, maybe in some parts of the US, a little bit through enormous uses of nitrogen fertilizer. But overall, we haven't increased it. That's what we have to work with. In order to use that well, we have to value it appropriately. And that's the carbon opportunity cost. So thank you very much, and I'll stop now.
Thank you so much, Tim, for that fantastic presentation. And really for sending home the idea that in a world with very limited planetary resources, like the one that we find ourselves on, opportunity cost, the carbon opportunity cost is a really, really big deal that really can't be neglected in the climate discourse. We've got a lot of questions flowing in from our community here. For those of you who have not yet gotten the chance to submit questions, please feel free to do so, and we'll try our best to get through them, whichever ones were not answered over the course of the presentation. One of the first questions that I'm seeing come in is really asking if you can clarify something we heard you say a couple times, which is that if land use is really factored in, if that carbon opportunity cost is really factored in, food is a bigger contributor to climate change than fossil fuels globally. Is that correct? Is food a larger contributor than energy?
No, I wouldn't say it's a larger contributor, but it's getting close. And to be clear, this is so one way to think about it is, what if we just stopped producing food, right? We magically can use solar energy to kind of make our food, like in Star Trek or whatever, you know. Well, for 30 years, we'd be able to sequester a huge amount of carbon as all this native vegetation regrows. And that would provide a gigantic offset. Now, eventually that would run out. So there's no way to solve climate change without also dealing with energy emissions. But since it's so important that we find ways to hold climate change down while we're figuring out how to do the rest of that in the next 30 years, we're valuing that using a kind of a time discounting value of money in a way, or of emissions. So it's kind of like additional. It's an additional cost that we typically ignore on the theory that these things have, this land has already been cleared.
Mm-hmm.
And of course, the alternative, though, is the land regrows, right? So if we didn't actually need it, and the alternative for any one of us, if we consume less, is that the world has to clear less land.
Super helpful. Thank you. This is a good segue into another question that we're getting from the audience, which is around that 30-year number for amortization. Where does that number come from? And would you change that number for land that has historically been used for much longer periods of time?
So the answer is no, you wouldn't change it for that. And the reason, there are kind of two reasons to think about it. So let's say you change your diet and you no longer need a hectare of land to be devoted annually to your food production. Now, in a world that's still clearing land, you've essentially saved a hectare of clearing. So that hectare of clearing would cause basically pretty immediate emissions of a large quantity. And then the question is, how do we count that? Well, we typically say, since we're focused on climate change the next 20, 30 years, we're going to divide by 20 or 30 years. So basically, your dietary changes contribute to the global land use change, even if in theory your product comes from already cleared land. So that's the basic reason it doesn't change. Now, where does the 30 years come from? Well, there's kind of a rough, or 20 or 30 years, there's kind of a rough way it comes from, and then there's kind of a rigorous way to justify it. The rough way is that governments, when they've had to deal with counting the emissions from direct land use change, have basically said we're going to use 20 or 30 years, which basically represents a policy judgment on where we really want to focus. What are the consequences? Now, we actually basically said, well, there's reasons we care about reducing emissions more quickly, or we're willing to pay more to reduce emissions quickly than in the long run. There are all these damages we're going to avoid in the period. We're holding down climate change so that we can figure out better solutions to solve climate change before it's too late. So we're buying time. We assigned a 4% discount rate to that, and you end up with something fairly close to 30 years when you do that and you look at the patterns of carbon loss. So there's a rigorous way to do it, and not. You could also think of it as like renting the carbon. Like, if imagine you're losing all this carbon, well, what's the cost of that? So what if you caused a ton of carbon loss, and I said, well, you have to offset that by paying somebody else to reduce a ton of carbon. Well, you'd have to go buy that. Well, let's say you borrowed money in order to pay for that. That guy charges you an interest rate of 4% per year. That's your rental cost. So there's a kind of rigorous economic explanation to that. So maybe more detail than anyone wants to know.
No, that was so great. Thank you, Tim. Um, there's a question here that wants to dig a little bit more deeply into carbon taxes. So this attendee shares that their novice understanding is that a carbon tax would be effective for greenhouse gases, but has not been as successful at actual implementation or institutional kind of global buy-in. Have taxes based on carbon opportunity cost of land been floated around? For example, the US government leases land to ranchers at extremely low costs, but from a climate perspective, it should be, in most cases, extremely high cost. So from your vantage point, what policies are you seeing being proposed or that you believe should be proposed to kind of correct for this?
Yeah, so politically, there doesn't seem to be any move toward carbon taxes, really. And my discussion of that was not because I think we should do that, or it's not worth that much discussing, because it's just not going to happen. But so the reason we have things like life cycle calculations or national reporting or anything else is because we want to at least inform ourselves of what actions cause emissions and what actions would reduce emissions. Now, the point is that for those surrogate accounting mechanisms to work, to work efficiently, they should tell you the same information as if there were a carbon tax. So if there were a carbon tax, you knew $100 a ton, you would know when you bought something how much carbon it caused, right? It would be built into the price. So we want to tell you the same amount of carbon. You may decide yourself how much you want to value it, or whether I want to do something about it or not, but we want to tell you the same amount of carbon. And that's why what we tell you has to include the carbon opportunity cost of land, because that is what you would be told if there were a perfect carbon price. So in fancy academic language, it's a heuristic, right? It's a thought exercise to allow us to think about how accounting should work.
Great, thank you. There are a few different questions here that I think are essentially driving at the same aim, which is to really understand the regenerative question a little bit more deeply. So one clarifying question that I think offers up a pretty good summation is just how can you clarify or can you clarify how you're estimating the inherent land costs for a random acre of land, for example? Because different ecosystems, soil types, and water availability were primary reasons for why human societies chose between growing crops or raising livestock in various areas and ecosystems. So how do you factor that into your research?
So the short answer is for any one food product, we say, where is that being produced and how much carbon has been lost on the land used to produce it? So so the land that's used for cropland to grow corn is generally got more carbon on it than the land that's used for grazing. So you count a higher cost. But that is divided by this massive amount of corn production and the fact that you're eating corn or whatever directly. And so therefore the land use costs are a lot lower. Now for beef, some of that land used for beef is native grazing land where you have no or very limited reduction in carbon. But about 40% of all the grazing land in the world is land that was forest or at least heavily wooded. So this is true of almost all the grazing land in Europe, much of the grazing land in Brazil, et cetera, et cetera. And so there that you have a carbon loss and that has to be factored in. So that's basically how you do it. You kind of you look at how much carbon has been lost from that food. And this is based on the following assumption that if you consume 1 kilogram of that product, it will be replaced or the cost of it is the cost on average to produce 1 kilogram of that product. Now, in the 2018 paper, we used a global cost where we have now regional costs that differ somewhat, but they're still roughly follow the same patterns. So it doesn't really affect that much whether you're using regional or global. If you factor in a land use cost, then everything changes.
Thanks, Tim. There is another question here about how the World Resources Institute is working on a new greenhouse gas emissions protocol that would presumably fix some of the problems you raised over the course of your presentation. Can you talk about how it's going and some of the challenges to changing the way that we count land use emissions?
So there are right now, the GHG protocol is this manual used by most companies to estimate their greenhouse gas emissions. And for the last several years, WRI has been going through a process to revise how it treats land use. And right now, there are very competing views. So one view is basically do no carbon opportunity cost, no land use cost, basically do all of the just direct land use change, all the things that kind of ignore that. And others are to factor in carbon opportunity costs. And it's the WRI is in kind of two positions here. We run a kind of a multi-stakeholder process to kind of gather views and try to reflect a multitude of views. But at the end of the day, WRI also puts its name on this product. So we're still having kind of getting the last advice from people on this. And actually those who want to influence this should kind of weigh in right now on their views on this, because those will be taken into account. The ability to make changes depends in part on the degree of support. So even though WRI, has its substantive view, it, public support from different constituencies matters.
That's really good to know. What is the mechanism by which people can provide input and feedback if they have perspectives to offer?
Well, I think they need to send a letter, basically. That's the best way to do it to our GHG protocol team. And I can suggest, and I'll put up an email address for people who want of the key person who would send it to. But that's basically the story.
Sounds good. Thank you. There is a question here about how we determine kind of the central value of land, whether and how you think about it in terms of carbon storage potential being the focus versus the land's ability to support and promote biodiversity. And essentially, I think the question boils down to whether you feel like there's enough of a discussion on the cost of biodiversity from land use change.
Well, obviously, I have a long history focused on biodiversity, and uh, that's another reason, of course, to reduce land use requirements. The overwhelming problem and threat for biodiversity is simply converting land to other uses. So, so if you want to preserve biodiversity, we actually probably we need to, given climate change and all those threats, even to preserve biodiversity, we need to actually restore a bunch of agricultural lands to habitat, let alone stop clearing land. So the overwhelming issue is to avoid clearing land. That would be, if you factored in a biodiversity cost, then the land use cost would be even more important.
Thank you. There's a kind of a fun question here about alternative sources of protein production and just it sounds like this person is growing a protein source on non-arable land using only seawater and sunlight.
Mhm.
Um, so from your perspective, is a standard life cycle analysis sufficient for understanding the environmental costs?
Well, if that on that description, the land use cost would be minimal or zero, and a proper life cycle calculation would give you credit for that. Now, it would only give you credit for that implicitly. I mean, credit meaning not you'd only benefit from that if it assigned a cost to those that do use land. So basically, it would be the absence of cost that would be the benefit.
Great, thank you. We've just got a few minutes left here. I think I will ask just a couple more questions before giving you an opportunity to share any last words and final thoughts with the community. Someone else is conducting an LCA and would love just overarching advice for how easy it is to calculate carbon opportunity costs for their region or their specific product. What data sources and data sets exist that they should kind of be drawing from. And I'll also put a plug in there for a life cycle analysis guide that GFI produced last year that you all might be able to make use of. But Tim, any commentary on data sources and
Yep.
database?
So the short answer is we actually kind of give you now the input for almost all inputs. So if you want to use a regional number or a global number, so we haven't published the regional numbers yet, but we're about to. We have published global numbers in the past. We're updating those. You could decide to use a regional number. You could decide to use a global number. You could decide to use half and half. Now, the real point is that when you consume food, no matter where it comes from, you don't really know where the expansion occurs to provide that additional food. So for an internationally traded good like corn, there's a good reason to use a global number. I would say the same true for beef. But you get counter arguments that no, well, maybe it's really just local. So sometimes we've used local, sometimes global. The point is that all you really need to do is just determine the amount of agricultural product that you have, multiply it by this carbon opportunity cost number, and there you've got it. Now, if you wanted to do that yourself, let's say you knew an individual farm, you can use an estimate, a map of the native carbon stock. You can say how much is growing here, how much have I lost, therefore, from the native carbon stock, and basically divide by 30. So there's ways to do it yourself if you want. But other than that, it's really just taking your ingredient list and multiplying it by the carbon opportunity cost, which is not that different from what people do for production emissions, right? You say, I'm using this much soybean, what's the production emissions of soybeans? You just multiply that by an emission factor. So this is really doing the same thing.
Thank you so much, Tim. I know there are some questions here that went unanswered. I am sure that there will be openness to kind of answering those questions in other spaces and forums. Thank you all for your active engagement and participation. Tim, this has been so fantastic. And I think it is clear to me that the alternative protein sector has some work to do to meet its promise of building a sustainable food system, but that the real potential is there for increasing food production on a smaller stretch of land, and that that alone should not be minimized. So thank you so much for taking us through this research. Super, super duper valuable. Are there any last words, comments, calls to action that you would like to leave our community of alternative protein scientists and innovators with as we wrap up today's seminar?
No, the only thing I'd say is that these are contentious issues, right? There are huge stakes involved. There are very powerful special interests who benefit from an accounting system that doesn't factor in the cost of land. So if you and accounting has just staggering power. We don't think about it. They're dry, they're dull. It's like, oh my God, painful to even think about accounting rules. But accounting rules determine whether or not something is good or bad. And if you have the wrong accounting rules, you end up just incentivizing all the wrong things. So it's worth making the effort to try to make sure that the accounting rules are sound if you're in your industry, I think.
Awesome. Thank you so much, Tim, for the
Amy,
seminar.
thanks for having me.
This has really been fantastic. And thank you to you and the World Resources Institute for always adding more critical nuance to these discussions. Thank you so much to everyone for your attendance. This was brilliant, and really appreciate all of you for engaging with this content. We look forward to seeing you again next month for our Science of Alt Protein seminar. Thanks again.
Thank you.
Bye, everyone. Thank you, Tim.